Hey everyone, how's it going? Welcome back to my channel. Lately on my channel, I've been talking about RTS or MOBA type games. I put out a video talking about Blitzcrank from League of Legends and doing a game mechanic breakdown of his rocket grab ability. I've also been putting out some Blender videos where I've been making a Blitzcrank model. Now the reason why I'm doing all of this is to get to the point where I can recreate Blitzcrank's rocket grab mechanic inside Unity. But because Blitzcrank's rocket grab is such a high level game mechanic, we first have to lay the groundwork and create all of the systems that are involved before we can get to that game mechanic. And so in the next few videos, I'm going to be going over some of the basic game mechanics that are needed for an RTS or MOBA type game. Now, a couple things that I want to mention before we get started is that one, I'm going to be using AI to help me code some of these more basic game mechanics. That way I can speed up the process and get to the actual game mechanics that I want to show you and be able to create. Now two, because I'm using AI for part of this project, I'm going to be providing the entire Unity project as a free download, which you can find in the description below. Now the third thing that I'd like to mention is that because some of this code was written with the assistance of AI, rather than pouring through all of the code and going through it line by line, I'd like to explain these game mechanics more in theory, similar to how I did the breakdown of Blitzcrank's rocket grab. This way you'll have a better understanding of how these game mechanics typically work, and whether you're coding your game from scratch or you're using AI to assist you, you'll know what to include in your game and what to look for in your code. Now let's get started. Alright, so here I have my Unity project so far, and I've actually gone through and implemented several game mechanics already. And so let's play through the project so you can get an idea of what I'm going for. Alright, so here I have this gray capsule object, which is my player object. And then I've got two red capsules, which are the enemies. I can then click anywhere on the ground, and a line renderer will appear between my player and where I clicked, and the player will begin moving in that direction. I can then also click on an enemy, and you can see my character is doing damage to their health. Currently my character has a bit of a range attack, which is actually just a distance variable that I could change in the inspector. Other game mechanics that I have currently are camera controls. I have the ability to follow the player, zoom in, zoom out, and I can unlock my camera and then move around when I move my mouse to the edge of the screen. And so in this video, let's just talk about player movement for RTS or MOBA type games. Now player movement in these games is pretty straightforward, and Unity makes it super easy. This is because Unity provides what's called a nav mesh system. This is a system that already handles a lot of the heavy lifting when it comes to figuring out player paths or moving an object from point A to point B. And before systems like this were created in the early days of RTSs, game developers would have had to code a similar system from scratch. Now, in this video, I'm not going to go into all the depths of how the nav mesh system works, but we can be grateful for those early RTS pioneers who created games like Warcraft, Command & Conquer, Age of Empire, because without those games, we'd be figuring out this game mechanic entirely from scratch. Now, to implement a basic RTS movement system, there's really three main parts. The first is our ground plane or our nav mesh surface. The next is our player or our nav mesh agent. And the third is our camera. So first is our ground plane or our nav mesh surface. Typically, these would be more complicated. There'd be ledges, ramps, walls, different obstacles to interact with. But the nav mesh surface basically designates all of the playable area. You then have your player object or your nav mesh agent, and it's this component that will figure out how to move the player from point A to point B. And so if we pick a certain point on our nav mesh system and we give it to the nav mesh agent, the nav mesh agent will then calculate a path and execute that path. Now the question is, in an RTS or a MOBA type game, how do we get that point on the map and give it to the player? And the answer is with the camera and player input. Now the easiest way to do this is to shoot a ray from the camera down to the nav mesh surface based on the mouse position. When the ray then intersects with the nav mesh surface, we can then get that point on the nav mesh and give it to the player. The nav mesh agent will then calculate a path from the player to that point, which we could then represent with a line renderer, and the rest of it's then taken care of by that heavy lifting of the nav mesh system. So now let's take a look at this Unity project and go through some of the setup and implementation. So first off, here I have my camera, which is up in the sky above the ground plane and player object, and it's just rotated down at a 45-degree angle. We then have our ground plane, which is just a ground plane that I scaled out to 10x and 10z. It has a mesh collider and the nav mesh surface component. All of these settings I've just left as default, and you'll need to click Bake. Before you click Bake, you'll want to make sure that you only have what you want for your environment in the scene. And so right now with my player object touching the ground plane, it would actually bake a hole in the playable area. So I could either move my player object up or disable it before I bake. Now, two other objects that you can create are the line renderer and a point indicator or a particle effect for where you click. For the line renderer, I just set the width to 0.1 and I set the color to green. And for the particle effect, I just have this green pulse effect. Next, I have my character object. This is just a capsule object, which I would eventually replace the visuals with a character model, such as my Blitzcrank model. Here I've attached the nav mesh agent component, and all of these settings as well I've left as default. Next, I have a new script, which I've called MOBA Character Movement Controller. And this, once again, is a AI-generated script. Now, to break it down simply, first off, we've got a bunch of variables related to movement, related to the line rendering and input. We got variables for the different components we're using, for finding a point and the different states the player is in, variables even for animation, and for working with the nav mesh. In the awake function, we're initializing different variables with different get components and setting our camera variable. In the start function, there's two main functions, one for setting up the nav mesh agent and the other for setting up our line renderer. In the nav mesh agent function, we're setting the different speed and braking and stopping distance and so on. In the line renderer, we're just making sure that the line is disabled to begin with, and we're setting the width. We then have the update function, and in the update function, there's four main functions, one for handling the movement and input, one for updating the movement state of the player, one for animation, once again. I haven't actually implemented this yet. And then another for updating the line renderer. In the movement and input function, the first thing that we're doing is getting the input from the player, whether they're clicking the left or right mouse button. I know different RTS and MOBA games have different inputs for controlling players. In games like StarCraft, the left mouse button would be for selecting your units, and then the right mouse button would be for moving and attacking. In games like League of Legends, where your character is always selected, the right mouse button is primarily used for moving and attacking, and then the left mouse button is used for hotkeys and abilities. I'm also currently just using the old input system for ease, but I'll probably update it to the new input system in the future. But for now, if you're using Unity 6.0 or later, you'll need to go into your player settings and enable the old input system. After getting the player's input, it's right here that you can see that we're doing that raycast that I talked about. And so to break this down, the ray is going from our camera to our mouse position using the screen to point ray function. This will create a ray that will go from our camera to where our mouse is pointing in world space. And if our camera is set up correctly, where it's up in the sky and angled down looking at the ground plane, then that ray is going to intersect with our nav mesh surface. This next if statement is checking our raycast to make sure that we hit an object, and if we didn't hit an object, then it's going to return. If we hit an object, then it's going to out the hit into this raycast hit variable. And it's in these next lines of code that we're getting the point where our ray intersects with that nav mesh surface, and we'll give it to our nav mesh agent in order to calculate a path and execute the path. So this if statement is checking to make sure that the point is on the nav mesh surface. If it is, then it'll out that point on the nav mesh using this nav mesh hit variable. We can then give that point to our nav mesh agent using the calculate path function. If it's able to calculate a path successfully, then we're going to give that point to this commit destination function. Inside this function, we're using the set path function of our nav mesh agent, and we're passing in this reusable path variable. This variable is used throughout the code to hold the calculated path. So right here where we're calculating the path, you can see we're also passing in this variable as a parameter. And it's actually this line of code that will start the process of moving the player object towards the target point. Now, one more thing that I want to show you in this code is with our line renderer. So if we go back up to the update function and we go to this fourth function, in this function, we're simply making sure that we have a line renderer and we also have a path. If we have a current path, then we're going to get all of the corners from that current path. So we have this variable called corners, and we're setting it equal to navagent.path.corners. The corners of the path essentially gives us all of the different points that we need for our line renderer. So if corners does not equal null and our length is greater than 1, then we're enabling our line renderer. We're setting the position count equal to corners.length, and then we're calling movement line renderer.setPath, and we're passing in corners. If we don't have a path, then we want to hide our line renderer. So I have this function, hide movement path. And in here, we're simply just checking to make sure that our line renderer isn't null and that our line renderer is enabled. And if it's enabled, but we don't have a path, then we want to disable it. And there you have the code for creating a basic move mechanic for an RTS or MOBA style game. And so now that you have a better understanding of how this game mechanic works, let's play through the project one more time so you can visualize it. All right, so here we're viewing our world through our camera's perspective. Our camera is looking down on the ground plane at a 45-degree angle. I also have my mouse, which I can move around. And if I click anywhere on the ground plane, we're going to shoot a ray from our camera to the mouse position in world space. That ray is then going to intersect with our ground plane or our nav mesh surface, and wherever that point is on our ground plane, we're then going to give to our player object or our nav mesh agent. Our nav mesh agent is then going to calculate the shortest path between its position and that position that we click. So here we go. Let's see that one more time. Now, I hope you have a better understanding of how basic movement works in RTS and MOBA style games. Now, once again, you can download this project for free, and I've provided a link in the description below. If you enjoyed this video, make sure you give it a thumbs up. If you have any questions or suggestions, leave them in the comments below, and make sure you subscribe to my channel so you can be up to date whenever I publish new videos. Thanks for watching, and we'll see you next time.